All right, guys. Today's going to be our first lesson for our last unit here, which is going to be over rational expressions here. All right, so let's go ahead and dive into it here. So we're going to have a lot of vocabulary here. So let's go ahead and just cover it. So the expression of 1 plus 1 over x is equivalent to the rational expression of x plus 1 over x. A rational expression is the quotient of two polynomials. You will find that at different times. It is helpful to think of rational expressions as ratios, as fractions, or as quotients. So you can use much of what you know about multiplying and dividing fractions to multiply and divide rational expressions. A rational expression is in simplest form when its numerator and denominator are polynomials that have no common divisors. So in simplest form, so some examples of some simplest form would either be like x plus 1 over x minus 1, x squared plus 3x plus 2 over x plus 3. Again, these are forms that cannot be simplified here. So that means that is in simplest form. Things that won't be are like x over x squared or 3 times x minus 3 over x minus 3. Even x squared minus x minus 6, and then so forth. So in this situation here, since these are not in simplest forms, you can tell that can be simplified because in that first example, we know that x over x squared can be simplified into 1 over x. So again, we need to simplify these in simplest form if possible. You simplify a rational expression by dividing out the common factors in the numerator and the denominator. Factor in the numerator and denominator will help you find the common divisors. So a rational expression in any simplified form must have the same domain in order to be equivalent. So if we had the equation of x squared minus x minus 6 over x squared plus x minus 2, you'd have to factor those first. So once you factored those and you had the factors of x minus 3 and x plus 2 and x minus 1 and x plus 2, you'd notice they both have x plus 2 on top and bottom. So we would cancel out the same factors on top and bottom, simplify it down to x minus 3 and x minus 1. And then the one that cancels out there, we then know that x cannot equal negative 2 because that's the one that we canceled out. So to figure out those parts, again, the ones that cancel out, then that's when we set that part equal to 0, solve for x, and that's what x cannot equal. So the ones that cancel out. All right. So in the example above, you must exclude negative 2 from the domain because negative 2 is not in the domain of our original equation. Note that this restriction is not evident from the simplified expression of x minus 3 and x minus 1. So again, whichever one is canceled out, set that factor equal to 0, solve for x. That's what x cannot equal. Okay. All right. So let's look at our first example here, simplifying a rational expression. So what is that in simplest form? State any restrictions on the variable. So again, our first step here, here's our equation. You have to factor that. So on your own here, make sure you have some paper that you can factor this. Use your AC method, right? And then go through those steps. So once you factor it, you should get the factors of x plus 2 and x plus 5 over x plus 2, x minus 5. From there, you notice that they both have the factors of x plus 2 and x plus 2 on top and bottom. So those get canceled out, which leaves me with a simplified form of x plus 5 over x minus 5. And again, the part that gets canceled out there, at x plus 2, we set equal to 0, solve for x. So that means from here, x plus 2 equals 0 will mean that x cannot equal negative 2. And again, that's our restriction. So if it asks for a restriction here, your answer would be x cannot equal negative 2. The simplified form would then be x plus 5 and x minus 5. Okay. All right, let's move on here. Multiplying rational expressions here. All right. What is the product of these two problems here in simplest form? State any restrictions on the variable. All right. So when multiplying here, your first step I would recommend would be to factor. If you can factor, always factor, get it down into simplest form here. Then from there, you'll be able to cross these out there. So after these are fully factored, now we can simplify from top and bottom here. So Since we have an x plus 3 on top and bottom here, those x plus 3's canceled out. Since we have an x minus 5 on top and bottom here, those can cancel out. So again, remember, whenever we multiply fractions, everything on top goes together, everything on bottom goes together. So even though they're in separate fractions, it doesn't matter that they're on separate fractions. As long as one's on top and one's on bottom, those can cancel out. So from here, we can cancel out x plus 3 and x minus 5, which would simplify this down to the left on top would be x minus 2 and x plus 5. On the bottom, we'd be left with x plus 1. So if that's the case, since that's what we're left with, again, the parts that we canceled out, we would set equal to 0 and solve for x. So in this instance there, we would set x plus 3 equals 0 and x minus 5 equal to 0, which means my two restrictions should be x equals negative 3, or x cannot equal negative 3, and x cannot equal 5. All right. Again, the restrictions part only comes from those that cancel out. So again, if it asks for that, make sure you understand that it doesn't matter what's on the denominator. It comes from what's canceled out. All right. And example 3 here, dividing rational expressions. So we saw multiplying. So here's dividing. So whenever we divide, we always want to do our keep, change, flip. We never want to divide fractions. So to do division, we're going to do keep, change, flip. Keep the first fraction the same, change multiplication or division to multiplication, and flip your fraction. So all we're going to do here is flip it. So as you can tell from this first part to the second part here, they kept it the same. They changed division to multiplication, and they flipped it. Then from there, you have to factor. So you have to get used to factoring, guys. Use your AC method and factor that equation out. So when everything's factored out, we'll have it left right here. So first things first, once it's factored, now we preferably would like to keep x in front here. So the way we're going to do that is if I factor out a negative 1, it ends up flipping that. So again, that negative x becomes a positive x. That positive 2 becomes a negative 2. So that's all they did there was just flip that to where x was in front. Then from there, you cancel out the like factor. So there's an x minus 2 on top and bottom. There's an x plus 1 on top and bottom. And those are the factors that they have in common. Then from there, we just leave everything as it is. Everything on top stays together. Everything on bottom stays together. So everything left on top would be the negative 1 and the x minus 1. Everything on bottom would be the x plus 1 and the x plus 5. Whatever was canceled out, that's what we set equal to 0. So I'm going to set that x minus 2 and that x plus 1 equal to 0. Solve for x. Those are going to be my restrictions. So my restrictions in this equation are going to end up being that x cannot equal negative 2 and x cannot equal negative 1. So those are my two restrictions. Okay. All right. Other than that, you do have homework, guys. Your homework will be due by 11:59 p.m. on Tuesday. Office hours will be from 1 p.m. to 2 p.m. And if you have any questions or concerns, please feel free to contact me. Again, you can do that through Remind. You can do that through email. Whatever way you need to get in touch with me, please feel like you can contact me if you have any questions about anything. Again, office hours are not mandatory, but again, highly recommended if you have questions. But other than that, guys, that's our lesson for today. Hope you guys are taking it easy, and I'll see you guys in office hours if you have any questions. All right, man. Bye.